Have we finally found life beyond Earth? For decades, that question has haunted scientists, philosophers, and dreamers alike. We've scanned the stars, listened for alien signals, and sent probes across the solar system, and every time, the universe answered with silence. But just recently, that silence may have been broken. Using the James Webb Space Telescope, astronomers pointed their instruments at a distant planet named K218b over 100 light years away. And what they found stunned the scientific world. Chemical fingerprints we've only ever seen on Earth. Molecules that shouldn't exist unless something alive is making them. This isn't speculation or science fiction. These are hard data, captured by the most advanced space telescope humanity has ever built. And if what we've detected is real, it could mean one thing. For the first time in history, we may have discovered alien life. K218b isn't just another exoplanet. First discovered in 2015 by NASA's Kepler mission, this world orbits a small red dwarf star in the constellation Leo. It's not a giant gas planet like Jupiter, nor a dry, rocky desert like Mars. Instead, it falls into a rare and fascinating category, a super-Earth. With a radius 2.6 times that of Earth and a mass 8.6 times greater, K218b is significantly larger than our homeworld, but much smaller than Neptune. This middle ground makes it particularly intriguing. It's big enough to hold a thick atmosphere, but potentially small enough to have a rocky or oceanic surface beneath it. Its location adds to the mystery. K218b orbits its star inside what astronomers call the habitable zone, the region where temperatures are just right for liquid water to exist on the surface. Water is the foundation of life as we know it, and finding planets in this Goldilocks zone is the holy grail of exoplanet research. Early models suggested K218b might be covered by vast, deep oceans beneath a hydrogen-rich atmosphere, a so-called Hycean world. These planets, neither purely rocky nor fully gaseous, could have conditions suitable for microbial life thriving beneath the clouds. But until the James Webb Space Telescope turned its golden mirrors toward this distant world, our understanding of it remained frustratingly incomplete. In 2023, that changed. The James Webb Space Telescope, equipped with cutting-edge infrared instruments, observed K218b during its transit when the planet passes directly in front of its star. This method, called transit spectroscopy, is a marvel of modern science. As starlight filters through the planet's atmosphere, molecules within it absorb specific wavelengths of light. From millions of kilometers away, Webb can detect these tiny variations and piece together the atmospheric composition of a world we cannot directly see. The findings stunned the scientific community. Webb detected methane, CH4 in significant amounts, carbon dioxide, CO2, another life-linked molecule, almost no ammonia NH3, which theoretical models predicted should be abundant if the planet were lifeless. On Earth, methane is typically produced by biological processes. Microbes, wetlands, and even livestock emit it constantly. Carbon dioxide, similarly, is tied to respiration and plant activity. More importantly, methane and carbon dioxide are unstable. Without constant replenishment, they break down. Seeing both gases together on K218b suggested an active, possibly even life-driven process, but it was what came next that sent shockwaves through astronomy. Amid these gases, Webb detected dimethyl sulfide, DMS, a complex molecule rarely found without biological origins. On Earth, DMS is almost exclusively produced by marine plankton, microscopic organisms floating in our oceans. These tiny life forms release DMS as part of their metabolic processes, contributing to cloud formation and even influencing our planet's climate. The detection of DMS on K218b wasn't a marginal note, it came with 99.7% confidence, making it highly unlikely to be a random fluctuation or instrumental artifact. Even more surprising, the estimated levels of DMS were hundreds of times greater than what we find in Earth's atmosphere. If these findings are confirmed, this would mark the first ever detection of a potential biological molecule outside our solar system. But science rarely gives us such clean answers, and not everyone is convinced. While the discovery is groundbreaking, scientists are cautious. History has taught us that false positives are common in the search for extraterrestrial life. Several non-biological explanations have been proposed. Exotic chemistry. Unusual reactions in hydrogen-rich atmospheres might mimic biological signatures. Comet impacts. Similar molecules could be delivered temporarily by icy bodies crashing into the atmosphere. Prebiotic processes, laboratory simulations show certain chemical pathways can create DMS-like compounds without living organisms. Furthermore, some researchers argue that K218b may not be a classic ocean world. It could be a mini Neptune with high-pressure ice layers and no liquid surface, a hostile environment for life as we know it. Healthy skepticism is vital. Astronomers know that before rewriting textbooks and declaring we found life, we need overwhelming, reproducible evidence. That's why Webb will revisit K2-18b multiple times, refining the data and searching for additional biosignatures. To understand how monumental this detection is, we must grasp the technological feat behind it. Observing an exoplanet's atmosphere is like trying to detect a single candle next to a massive floodlight from thousands of miles away. Webb's instruments, near-infrared spectrograph, NIRS-SPEC, and mid-infrared instrument, MIRI, are designed to capture faint, telltale signs of atmospheric molecules. Every gas leaves a unique barcode in light, allowing scientists to identify its presence. This technique is so sensitive it can measure differences of just a few parts per million. In K2-18b's case, Webb not only detected gases but also inferred temperature gradients, atmospheric pressures, and potential cloud layers, giving us an unparalleled look at a potentially habitable exoplanet. To truly appreciate this moment, consider how far we've come. In 1992, the first exoplanets were discovered around a pulsar, a dying star. At the time, even confirming a planet around a normal star seemed impossible. Fast forward to today. We've cataloged over 5,500 exoplanets with thousands more candidates awaiting confirmation. We've found worlds with scorching hot ice, super-Earths larger than their suns, and gas giants whirling so close to their stars that their atmospheres are being blown away. Each discovery has brought us closer to answering a profound question. How common is life in the universe? The detection of DMS on K2-18b may be the most compelling piece of that puzzle yet. K2-18b may be stealing headlines, but it's far from the only candidate in our search for alien life. In fact, our galaxy is bursting with possibilities, and every year, astronomers uncover new worlds that challenge our understanding of what's habitable. Take the TRAPPIST-1 system. Located just 40 light-years away, it's a red dwarf star surrounded by 7 Earth-sized planets, 3 of which, TRAPPIST-1, E, F, and G, lie within the habitable zone. These planets are locked in a cosmic dance so tight that standing on one of their surfaces, you might see neighboring planets loom in the sky, closer than our moon appears on Earth. Scientists believe that at least some of these worlds could host ocean beneath protective atmospheres, shielded from the harsh radiation of their tiny star. Then there's Kepler-4 52b, often called Earth's cousin. Discovered in 2015, it orbits a sun-like star in nearly the same position as Earth does, leading many to wonder if it could be a home away from home. Although it's about 60% larger than Earth, its rocky surface and potential for liquid water make it one of the most Earth-like exoplanets ever found. Closer still is L9859f, a planet just 35 light-years from us. This world is particularly fascinating because evidence suggests it may be covered entirely by oceans, a water world glinting under alien starlight. Imagine vast, endless seas without a single continent, teeming with unknown marine life forms. And these are just the confirmed candidates. Statistically, based on current data, astronomers estimate that the Milky Way could contain billions of habitable planets. Every star you see in the night sky might have its own version of Earth, or something even stranger. The discovery of DMS on K2-18b is not the end of the story. It's the beginning of a new era of exploration. The James Webb Space Telescope has given us a taste of what's possible, but the next generation of observatories will push us into uncharted territory. The upcoming Extremely Large Telescope, ELT, in Chile, with its massive 39-meter mirror, will peer deeper into the cosmos than any ground-based telescope ever has. It will be capable of directly imaging exoplanets, not just inferring their presence through wobbles and shadows. With its advanced spectrographs, ELT could detect reflected light from alien oceans or even seasonal vegetation changes, signs that go beyond chemical hints and move toward visual confirmation of life. The Giant Magellan Telescope, GMT, also under construction in Chile, will complement ELT with unparalleled sensitivity. Scientists hope GMT could distinguish between planets with thick, choking atmospheres and those with clear skies, where the blue hue of an alien ocean might be visible against the blackness of space. NASA's proposed Habitable Worlds Observatory, HWO, takes it even further. Unlike Webb, which primarily uses starlight filtering, HWO will carry coronagraphs and starshades, technologies designed to block out a star's glare, allowing us to see its planets directly. For the first time, humanity might capture actual images of alien continents, polar ice caps, or swirling weather systems on distant worlds. And this is just the beginning. The long-term dream is interstellar probes, robotic spacecraft capable of reaching nearby star systems like Alpha Centauri or TRAPPIST-1. Projects like Breakthrough Starshot are already exploring technologies to send tiny, light-powered probes traveling at a fraction of the speed of light. Within decades, these could fly past exoplanets and beam back real photographs of alien worlds, something that today feels like science fiction. If and when life is confirmed on another planet, the impact on humanity will be seismic, far greater than landing on the moon or even discovering fire. Religions around the globe will face new interpretations of creation and divinity. Some may see alien life as proof that life is a universal gift, others as a challenge to long-held beliefs. Philosophers will ask, if life arose independently elsewhere, does it mean intelligence is inevitable or a rare cosmic accident? Science and technology would be propelled into overdrive. Funding for space exploration would skyrocket. Entire fields, from biology to chemistry to robotics, would shift focus to studying how alien organisms survive, evolve, and interact with their environments. We'd be forced to reconsider what life truly means, expanding it beyond our Earth-centric definitions. Socially, it could unite humanity. For centuries, nations have been divided by borders and conflicts, but the realization that we are one species among many in the cosmos could foster unprecedented cooperation. Our survival and exploration of the universe would become a shared mission, transcending politics and geography. And yet, it could also provoke fear. Discovering life might mean realizing we're not the pinnacle of evolution. Worse, it might suggest that advanced civilizations have risen and fallen long before us, leaving only biosignatures behind. The Great Filter theory, an idea that intelligent life tends to self-destruct, would loom large over humanity's future. Ultimately, the confirmation of alien life would force us to confront a humbling, exhilarating truth. The universe is alive, and our journey as a species has only just begun. Today, K218b remains a tantalizing enigma. The chemical signatures we've detected could be the first whispers of life beyond Earth, or a complex, lifeless chemistry we've yet to understand. But what's undeniable is that we stand on the brink of a cosmic revelation. Every new observation, every refined data point brings us closer to answering humanity's oldest question. For billions of years, the universe has been silent. But perhaps it's not empty. Perhaps, as James Webb peers deeper into the darkness, we'll soon realize that we've never truly been alone.